Hello, my name is Harika. I am from BVC Engineering College. In this lecture, I will talk about the single stage amplifiers. This is the lecture outline. First, we'll see the introduction, classification of amplifiers, and then we'll see the single stage transistor amplifier like a common emitter amplifier, common base amplifier, common collector amplifier, and then we'll see the comparison of common base, common emitter and common collector amplifiers. Now coming to introduction. One may ask, what is an amplifier? An electronic signal contains some information which cannot be utilized if it does not have proper strength. The process of increasing signal strength is called amplification. Simply, we can define an amplifier is an electronic circuit that can increase the strength of a signal. And amplifiers are used in many applications, like in the medical devices, scientific equipment, automation, military tools, communication devices, and even in household equipment. For example, in the medical sector, amplifiers are used to record the ECG and EMG signals. And in the household equipment, a simple example, if we consider a home theater. So in the home theater, we are using the audio powered amplifiers. This is the classification of amplifiers. Amplifiers are classified according to many considerations, based on the number of stages, based upon its output, based on the input signal is applied to the amplifier, based upon the frequency range, means at which frequency we are using your amplifier, based on biasing conditions, based on coupling method, and based on transistor configurations. Now we understand the classification of amplifiers. That's based on the number of stages. Depending upon the number of stages of amplification, there are single stage amplifiers and multi-stage amplifiers. In single stage amplifiers, is used only the one transistor circuit to amplify the signals. And in the multi-stage amplifiers, we are using the cascading of the single stage amplifiers are used to amplify the signal. So by using cascading of these amplifiers, we can increase the signal strength more compared with the single stage amplifier. Next, classification is based upon the output. Depending upon the parameter that is amplified at the output, there are two types of amplifiers: voltage amplifier and power amplifier. The amplifier circuit that increases the voltage level of the input signal is called voltage amplifier. The amplifier circuit that increases the power level of the input signal is called power amplifier. Based on the input signals. Based upon the input signal applied to the amplifier, there are two types of amplifiers: small signal amplifiers and large signal amplifiers. When the input signal is so weak to produce a small fluctuations in the collector current compared to its quiescent value, the amplifier is known as small signal amplifier. Example of this small signal amplifier is voltage amplifiers. Large signal amplifiers. When the fluctuations in the collector current are large, beyond the linear portion of its characteristics, the amplifier is called large signal amplifier. Example of this large signal amplifier is power amplifier. Based on the frequency range, the amplifiers is classified into different types: audio amplifiers, radio amplifiers, video amplifiers. In this, we see the audio amplifiers and the radio amplifiers. The amplifier circuit amplifies the signal that lies in the audio frequency range, that is from 20 Hz to 20 kHz frequency range, is called audio amplifier. Radio amplifier. The amplifier circuit that amplifies the signals that lies in the radio frequency range is called as radio amplifiers. For audio amplifiers, we can give the example as multi-stage amplifiers. Radio amplifiers, we give the example is the tune amplifiers. So the tune amplifiers, we can take the output from the tank circuit, whereas in audio amplifiers, we can take the output from the load resistors. Now, based on the biasing conditions, the class A amplifier, class B amplifier, and a class C amplifier and class AB power amplifiers. These amplifiers are also called as power amplifiers or the last signal amplifiers. In class A amplifier, the biasing condition such that the collector current flows for entire applied AC input signal. In class B amplifier, the biasing condition in class B or the collector current flows for only off cycle of the input signal. In class C amplifier, the biasing condition of the amplifier such that the collector current flows for less than off cycle of input signal is applied. This class C amplifier is also used at radio frequency range. Class AB amplifier. In class AB amplifier is one which is created by combining both class A and class B in order to have all the advantages of both the classes and to minimize the problems that have. All these amplifiers are power amplifiers, and these are also called as last signal amplifiers. And these amplifiers mainly used at last stage at multi-stage amplifiers. Depending upon the method of coupling one stage to the other stage, there are RC coupled, transformer coupled, and direct coupled amplifiers. In RC coupled amplifier is a multi-stage amplifier that is coupled one stage to the other stage by using resistor and capacitor combination. In transformer coupled amplifier, the output of the one stage is coupled to the next stage with the help of transformer. Whereas in the direct coupled amplifier, next stage is directly connected without using any RC combination elements or the transformer elements. These three amplifiers are the examples of multi-stage amplifiers. Next classification will see the based on transistor configuration. Depending upon the type of the transistor configuration, there are three types of amplifiers: common emitter, common base, common collector amplifier. By its name itself, you can understand what is the type of configuration is used in that amplifier. In CE amplifier, common emitter configuration, transistor is used, and the amplifier circuit that is formed using a common base configuration, transistor, and it is called common base amplifier. In the common collector amplifier, the circuit is formed using common collector configured transistor combination. And we can also tell these three amplifiers are also example of single stage amplifiers. Now we'll see single stage transistor amplifier. When only one transistor with associated circuitry is used for amplifying the weak signal, that circuit is called single stage amplifier, as like this. This transistor amplifier circuit has one transistor and biasing circuit and other components. when weak input signal is applied at base of this transistor, a small amount of the current flows to the base. Due to the transistor action, a larger current flows in the collector of the transistor. Because we have the relation of this collector current and the base current, that is IC is equal to beta into IB, where beta is called current gain of the transistor. Now, as the collector current increases, the voltage drop across the collector resistance RC is also increases, which is called as the output. Then we can say that a small input is applied at the base of the transistor. That signal of larger magnitude and strength in the collector output. Hence, this transistor acts as an amplifier. This figure represents the practical circuit of transistor amplifier, and this is also called as voltage divider biasing circuit. In this circuit, the biasing circuit is R1, R2 and RE resistance, which helps in establishing a proper operating point. And the input capacitor is C in. This capacitor main function is couples the input signal to the base of the transistor. The input capacitor allows AC signals but isolates the signal source from R2 resistor. When this capacitor is not present, the input signal gets directly applied, which changes the biasing at R2 resistor. In the circuit, we have the coupling capacitor is the CC. This capacitor is present at the end of the one stage and connects it to other stage. As it couples two stages, it is called as coupling capacitor. This capacitor blocks the DC of one stage to enter the other, but allows the AC to pass. So this is also called as a blocking capacitor. Due to the presence of this coupling capacitor, the output across the load resistor RL is free from the collector's DC voltage. If this coupling capacitor is not present, the bias conditions of the next stage will be drastically changed due to the shunting effect of collector resistance RC, as it would comes in parallel to the R2 of the next stage. Next in the circuit we have emitter bypass capacitor CE. This emitter bypass capacitor is parallel to the emitter resistor RE. The amplified AC signal is bypassed through this. If this is not present in the circuit, the signal will pass through emitter resistor RE, which produces the voltage drop across the RE. That will feed back the input signal, reducing the output voltage. And next we have the load resistor is RL. The resistance RL is connected at the output, is known as load resistor. When a number of stages are used, the RL represents the input resistance of the next stage. Now we will see the various circuit currents in the practical circuit. First we will go with the base current. When no signal is applied to the base current, DC base current IB, this DC base current IB is represented with the capital letters, flows due to biasing circuit. When AC signal is applied, AC bias current IB, with this we can represent with the small letters. Then when signal is applied, the total base current is the sum of the DC current and AC current. Now see, the collector current is the IC. When no signal is applied, a DC collector current IC flows due to the biasing circuit. When AC signal is applied, AC collector current is flows. Then the total current in the collector also is the sum of DC and the AC. And this collector current, you already know that as this is the beta into IB. Zero signal collector current and collector current due to the signal for the DC and the AC cases. Now similarly we have the emitter current. And this emitter current also is a sum of both DC current and the AC current. DC current is when no input signal is applied. AC current is when signal is applied. It should be remembered that the emitter current is a function of as a sum of base current and the collector current. And the collector current is nearly equal to the emitter current. This is used as a practical circuit. Now we will see the single stage amplifiers, and these also comes in the category of based on the configurations. Any transistor amplifier uses a transistor to amplify the signals which is connected in one of the three configurations. For an amplifier, it is better state to have high input impedance in order to avoid loading effect in multi-stage circuit, and lower output impedance in order to deliver maximum output to the load. The voltage gain and the power gain should also be high to produce a better output. Means that amplifier circuit is good if it is having the high input impedance and low output impedance for the better results. This is one of the single stage amplifier. That is common base amplifier. This figure represents common base configured transistor circuit using NPN transistor. Here the base is a common terminal for the input and the output. The input signal is applied at the emitter base junction, and the output signal is taken from the collector and base junction. Means input is a emitter terminal and output is a collector terminal. And this transistor is biased using emitter base junction is in the forward biased and collector and base junction is in the reverse biased, with the biasing voltages VEE and VCC respectively. The operating point is adjusted with the help of the resistors, emitter resistor RE and collector resistor is the RC. The values of IC, IB are decided by the biasing voltages VCC, VEE, RE and RC. Here the CC is the coupling capacitors at the input and the output. That is at the input, this is also called as an input capacitor. What is thing we discussed in the last one. And CC is the output capacitor, and this is also used to couple the output to the next stage. And the positive going pulse of the input source increases, the emitter increases. The positive going pulse of the input source increases the emitter voltage. As the base voltage is a constant, the forward bias of emitter base junction reduces. As the forward bias voltage at emitter base junction is reduces, then the base current IB is decreased, then your IC is also decreases. Because in between we have the IC and the IB. IC is equal to beta into IB. So as a positive going signal is increases, that decreases the forward bias voltage between emitter and the base. Then your base current is decreases. And the output we are taking at a collector terminal, and if you take that drop across your collector resistance is RC, VC is equal to IC RC. So as IB is decreases means IC is also decreases. Then the output between the base and your collector, that is a VCB. Okay, the VCB we can write it as biasing voltage VCC minus IC RC. So when the positive going signal is at the input, produces the positive going output, and similarly negative going input produces the negative going output. So there is no phase shift between the input and output of output in a common base amplifier. And this common base amplifier offers very low input impedance and very high output impedance. It is mainly used at the input stage of the multi-stage amplifier. Next we will see the common emitter amplifier. This is the one of the single stage amplifier. This figure shows common emitter amplifier circuit using NPN transistor. It consists of different components like your practical transistor amplifier circuit, what you discussed in the previous slides. It is having the biasing circuit with resistors R1, R2 and RE. These resistors forms a voltage divider biasing circuit for the CE amplifier. It sets these biasing circuits sets the proper operating point of the CE amplifier. And the input capacitor is the CN. This couples the input signal to the base of the transistor. It blocks any DC component present in the input signal. That passes only the AC signal for amplification. And next we are having emitter bypass capacitor is the CE. So you already know that the function of the bypass capacitor. Usually it provides a low reactance path to the amplified AC signal. If it is not present in the AC signal, that AC signal passes to the emitter resistor, will cause the voltage drop across it. Then the output voltage is decreases. So we can't get the required gain of the amplifier if we are not using this bypass capacitor. And the coupling capacitor. This is used to couple of this stage output to the next stage. Now, when input signal is applied at the base and emitter of the transistor, and the output signal is taken between your collector and the emitter. When no input signal is applied, there is no output. When a positive off cycle of the input signal is applied, the voltage between base and emitter is increased because it is already positive with respect to the ground. As forward bias is increases, the base current is also increases. Then your collector current IC is increased. So the signal is amplified. But at your collector, voltage drop at a collector resistor is RC, it is VC equal to AC RC. Because of this voltage drop, the output between the collector and the emitter is VC is equal to VCC minus IC RC. Because of this one, we will get the phase differential in the common emitter amplifier. Then positive going signal is applied at input, so your collector current is also increases positively, that your collector voltage VC equal to IC RC. But the voltage drop between the collector and the emitter, VC is equal to VCC minus IC RC. The increase in IC results in a drop in a collector voltage is a VC, as VCC is a constant. Thus, VA is increases in a positive direction, so output voltage is goes in a negative direction, and we will get the negative off cycle output voltage for the positive off cycle at input signal. Similarly, for the negative off cycle of input, the input is a negative off cycle, so output voltage goes in the positive direction, and we will get the positive off cycle of output voltage for negative off cycle of input signal. This gives the phase difference of 180 degrees. Means in the CE amplifier, we will get the phase shift between the applied input signal and the amplified signal. The input impedance of the CE amplifier and the output impedance of the CE amplifier are better than the CB amplifier, and the voltage gain and power gain also high in the CE amplifier, and it is mostly used in the audio amplifiers condition. Now we will go with the common collector amplifier. Common collector amplifier. This figure shows common collector amplifier. The DC biasing is provided by here R1, R2 and RE resistors. The load resistance is capacitor coupled to the emitter terminal of the transistor, because in the common collector amplifier, the common terminal is a collector terminal and input terminal is the base and output terminal is a collector. When input signal is applied via C1 of the base of the transistor, the base voltage VB is increased and decreased as the signal goes positive and negative. That means the collector current is increases for the positive cycle and for the decreases for the negative cycle. We can write that the emitter voltage across your resistor, emitter resistor is RE, VE equal to VB minus VBE. Considering the VBE, the drop between the base and the emitter is a constant, we say that variations in the base voltage appears at emitter, and emitter voltage VE will vary same as the base voltage is the VB. Since the emitter is output terminal, it can be noted that the output voltage from a collector circuit is same as its input voltage. Simply we can say that in common collector circuit, emitter terminal follows the signal voltage applied to the base. Because of this reason, the common collector circuit is also known as emitter follower. And this common collector circuit offers a high input impedance and low output impedance, and its current gain is very high, but its voltage gain is low, because the voltage gain is low because the input is supplied at the base and output is taken at the emitter, so both are comes into the same loop. So usually this voltage gain is nearly unity. Now see the comparison between the single stage amplifiers CV, CA and CC amplifier. So these we can compare with the help of taking the some characteristics like its input resistances, output resistances, and its current gain and the voltage gain. Okay, basically first we can go with the input resistance. In common case amplifier, the input resistance is very low, and whereas in the common emitter that input resistance is low, means it is somewhat higher than the common base configuration, whereas in the common collector the input impedance is very high. Now coming to the output resistance, in the common base the output resistance is very high. In the common emitter it is high, that is 40 kilo ohms, and the common collector it is very low. And you already know that what is the input terminal and output terminals of these amplifiers. According to that we can also tell it is the input current and the output current. Now see, in the input current of common base is the emitter current is the IE, in the common emitter is the IB, in the common collector is the again base is the input, so input current is the IB. Output current, in the common base the output is a collector, so the collector current IC acts like an output current. In the common emitter also the output terminal is a collector, so here also that output current is IC, and in the common collector the output is we are taking from the emitter terminal, so we can write output current is a, emitter current is a IE. So the input voltage is supplied in the common base is between the emitter and the base, whereas in the common emitter, base and the emitter, common collector, base and the collector. Output voltage is taken from in common base, so output terminal is the collector, so we can take that voltage also between your collector and the common terminal, that is the collector and the base. In the common emitter the output is taken between the collector and the emitter, whereas in the common collector the output is taken between your emitter and the collector. Current gains. So in the common base the input current is the emitter current is IE, and your output current is the collector current is IC. Usually the gain is defined as the output by input, so the current gain is the output current by input current. So in the common base the output current is IC, so IC by input current is the IE, so IE. Usually in the transistor action the collector current and emitter current is nearly equal, so that's the reason why the current gain of the common base is less than unity. That is, we can also tell that is nearly equal to 1 also. So in the common emitter configuration, if you see that current gain is high, because here the output current is the IC and input current is the IB. So the ratio is, we can write IC by IB. So IB value is very small because the base is lightly doped. So, and we also other relation, your IC is equal to the beta into IB. So we can write beta is equal to IC by IB. So IB is a very small base, so obviously its beta value is so current gain is very high. In the common collector also same, the current gain is very high because input current is the base current and output current is the emitter current. And coming to the voltage gains, So these voltage gains also gives the ratio of output voltage by input voltage. So in the common base and common emitter cases, this voltage gain is medium, and compared with the common base, in the common emitter voltage gain is high, and where is in the common collector, that is low. So means that value is nearly equal to the unity. And now go the applications of common base. It is simply used as an input stage of the multi-stage amplifier, because it is having the very low input resistance. So because of this feature, we can connect the low input signals of this. So we can use this is as an input stage of the multi-stage amplifier. And common emitter, this is used for the audio signal amplification, and this common emitter is used as the intermediate stages in the multi-stage amplifier. And whereas the common collector, this is mainly used for the impedance matching. And in the multi-stage amplifier, we can prefer this common collector stage at the last stage, so to match the impedance between the amplified signal and the load. So this is about the comparison between these three amplifiers. Based upon these operations and the features, that is characteristics of these amplifiers, and these we can prefer in your multi-stage amplifier for cascading the normal single-stage amplifiers. So till now we discussed about what is amplifier and its applications and the classification of the applications, and then we talked about the single-stage transistor amplifier circuit as a practical circuit with the help of coupling elements, biasing elements, to bypass capacitor and biasing voltages. And then we talked about single-stage amplifiers, and we see the comparisons of between these single-stage amplifiers. So with this, I would like to conclude. Thank you very much.